Okay, so we were just talking about theorem number 3, the triangle midsegment theorem, right? So if a segment joining the midpoints, which is a midsegment of two sides of a triangle, it's parallel to the third side and half the length. So if I have a midsegment, I know that it's parallel and half the length. If I know that a segment is parallel and half the length, then it connects the midpoints. So the reverse is true as well. So here we have two lines that are parallel, and 8 is half of 6, right? So this must be a midsegment. What that means is it breaks this line segment up into equal pieces and breaks this one up into equal pieces. Notice I didn't use 1 for every one, right? All 4 of these are not equal. These 2 are equal because it's splitting this in half. And then CD and AD are equal. Alright, so over here, I have the congruence notation. That makes V a midpoint, right? V is a midpoint. I have this congruence notation, which makes U a midpoint. So I know that VU is a midsegment. A midsegment? What am I writing? Midsegment. And if I have a midsegment, I know two things. I know that it's parallel to the third side, which can help me with angle relationships, and I know that it's the half the length. So if VU is 9, that means DF must be 18. Alright, let's go ahead and try example 13 and 14. Alright, so find the measure of x. So looking at this, I see that BP and PA are both 8. So I know that P is a midpoint. It's right in the middle. Same on this side. I see 9 and 9, so I know that Q must be a midpoint as well. So that means, I got a midsegment. PQ is a midsegment. And if I got one of those, I've got two things. It's parallel to the third side, and it's half the length. So looking at it, it's half of 6. So what's half of 6? X equals 3. My midsegment is 3. Alright, number 14. If M equals 15, so we'll say M equals 15, what is the measure of K? Alright, so do I have a midsegment? Does it tell me anything about A to E or E to B? No, I don't see any measurement or congruence notation. I don't see any measurement or congruence notation on this side. I don't have enough to conclude that this is a midsegment. So not enough information to find K. I just can't do it. I'm sorry. Alright. Next page. Alright, I want you to pause the video and I want you to try number 15 and 16 on your own. We'll review them in class. Be prepared to come up to the board and do these. Alright, number 17 I'll do, and then you're going to do number 18. So solve for x. Let's see, do I have a midsegment? I know that Q is a midpoint, right? Because it's right in the middle. I've got those congruence notations, and I know that R is a midpoint as well because of the congruence notations. So if I have two midpoints and a line segment connecting them, I know that QR is a midsegment. Alright, if I've got a midsegment, I know it's parallel to the third side and half the length, right? So if I take this right here and I multiply it by 2, I should get this length, right? Because it's half of it. This little length, this midsegment, if I multiply it by 2, I get the longer side. So I'm going to write that out as 2 times the length of the midsegment equals the length of third side. It's a little messy, but you get what I'm saying, right? Because the length of the midsegment is half of the third side. So let's just plug everything in. 2 times 2x minus 3 is equal to x plus 9. Here's my midsegment. Here's my third side. I know if I take this midsegment and multiply it by 2, and I can prove that over here, right? My last page, if I took 3 and multiplied it by 2, I got 6, right? If I took 8 and multiplied it by 2, I got 16. All right, this is bringing back a little distributive property. So 2 times 2x gives me 4x. 2 times negative 3 gives me negative 6 equals x plus 9. I want to get x on one side, so I'm going to subtract x on both sides. And I'm left with 3x minus 6 equals 9. I want to add 6 to both sides. And I'm going to move the problem over here to have more room. So I'm left with 3x equals 9 plus 6 is 15. Divide both sides by 3, and you get x equals 5. So as long as you know that you've got a mid-segment, you know the relationship between the two, right? All right, go ahead and do example 18 on your own. So pause the video and do 18, and then we'll go over that in class. All right, number 19. So we're going to use this diagram for the next 4 questions. I've copied it onto the different problems because we're going to write on it. So if AC is 16 feet, AC is 16 feet, AT is 20 feet, and CT is 26 feet. What is the perimeter of parallelogram, and I'm going to connect the dots here, ADGO? All right. So let's see what we got here. Okay, and one thing that the problem forgot to mention, I must have deleted it out. I apologize about that, but this is important. D is the midpoint of AC. O is the midpoint of AT. And G is the midpoint of CT. And that's the same for all the next 4 problems. So sorry I left out the dog. All right, so if I know I've got midpoints, then I've also got mid-segments, right? Because the lines connect the midpoints. So looking at this, it would be helpful to know DG, right? So it's a line that connects midpoints so that I know it's parallel to the third side and half the length. So looking at DG, it must be half the length of AT, right? So this must be 10. And if I know it's a parallelogram, the opposite side is 10 as well. Okay, can I figure out what OG is over here? I know it's parallel to the third side and half the length. So from A to C is 16, so O to G must be 8. So if that side is 8, this side is 8 as well. All right, if I'm trying to find the perimeter, I know the perimeter is just going to add up all the sides. So 10 plus 10 plus 8 plus 8. So my perimeter must be 36 feet. Be sure and use the units just to be exact. All right. So using on the next 4 problems that I want you to attempt on your own, I want you to assume the same thing, that D, O, and G are the midpoints. So you can apply that midpoint theorem. So on the next page, you're going to do these on your own. So pause the video and do 20, 21, and 22 on your own, and we're going to go over them in class. All right. Hopefully you've worked those out. You'll be going to the board and working them out. All right, so let's summarize the 3 theorems that we've gotten so far. I know you're getting tired of this, but all anterior angles of a triangle sum to 180. All right, base angles of isosceles triangles are congruent. And then my last one, a line segment connecting midpoints of a triangle is parallel to the third side and half the length. Ooh, that was a doozy. All right, we're ready for our fourth and final theorem. That's going to be the centroid measure theorem. All right, so for the centroid measure theorem, we're going to talk about medians. So a median is a segment connecting the vertex of a triangle to the midpoint of the opposite side. So a vertex is just a point, right? So C to P, CP is a median. What other medians do you see? I hope you said A to N, this vertex to this midpoint, and then B to M. Those are all three medians. All right. Now, the medians, see how we have three because we've got three vertexes, right? The medians of a triangle meet at a point known as the centroid, also known as the balancing point of the triangle. So the centroid actually cuts each median into two segments with a ratio of 2 to 1. So 2 to 1, 2 to 1. All right, so let's go ahead and use this to solve some problems. Number 1, in triangle XYZ, YW is a median. All right, so I know that automatically W is a midpoint, right? Because if this is a median, it breaks those into two sides. All right, what is XW if XZ, so X to Z is 17. Well, basically, all you're saying is that you know a median connects to a midpoint. So if these two are equal, then I'm just going to take 17 divided by 2, and I'm going to get 8.5. So each of these is equal, and it's 8.5. So XW is equal to 8.5. All right. Go ahead and try number 2 on your own. Pause the video and try number 2. All right, I'm going to move on here. In triangle DEF, DS, FR, and ET are medians. All right, so that tells us a lot about this triangle. I know that each of these are midpoints, so I can go ahead and say that it splits each of these in half, right? All right, so find EV if VT is 5. So from V to T is 5, and we need to find EV. All right, so if it's a ratio of 2 to 1, right? Remember the centroid right here. The centroid splits up ET in a ratio of 2 to 5. So what's 2 5s? 5 times 2 gives me 10. So EV is going to be 5 times 2, which gives me 10. So a ratio of 2 parts to 1 part. So EV is equal to 10. All right, looking at this, if FR, so this whole median, the whole median FR is equal to 20.1, what is the measure of VR? All right, so I've got 3 parts in here, right? 1 part and 2 parts here. So I know if I label this X, then this has to be 2X, right? 1 part, 2 parts. So I would say X plus 2X would give me 20.1 if the whole thing is 20.1. So when I combine these, I get 3X equals 20.1. Divide both sides by 3, and I'm going to get X equals 6.7. So I know that X is the measure of VR because that's my 1 part, right? Not my 2 points. So I know that VR is also equal to 6.7. If the problem were asking me for FV, the longer part of the median, I would say 2 times 6.7. And I would get 13.4. Now if I did my problem right, these two should sum up to my median length. So my 6.7 plus my 13.4 should sum up to 20.1, and it does. All right. I want you to go ahead and try 5, 6, 8, 9, and 10 on your own.